Hi and Assalamu alaikum. My name is Arisha Hanmiti Azman and my metric number is CD190070 and we are from group 7 and we are going to present topic 2 for tensile test. I am going to talk about the introduction, objectives and the procedures of this experiment. Many products and components are subjected to torsional forces during their operation. By testing this product in torsion, manufacturers are able to stimulate real-life services condition, check product quality, verify designs, and ensure proper manufacturing technique. There are two kinds of torsion experiments, which is torque control and angular speed control. In this experiment, we will conduct the angular speed control. The angular speed control turns the specimen at a specific angular speed while the torque is measured. The objectives of this experiment are to determine the elastic and yield behavior of material when subjected by torque load, be able to plot the graph of twisting angle versus load torque, and to compare the value of modulus of rigidity from the experiment with the theory. The procedures are: first, we record the specimen, which is the breast and mild steel shaft length and diameter, and were measured at different locations, and the average of the length and diameter were calculated. The pulley length were measured too. Then we record the data in table 1. Then the torsion specimen was mounted in the testing machine and the pulley must be in horizontal position. The angle indicator was placed and the reading was set at 0 before placing the load at the machine. Next, the angle of twist were measured when the load was placed and added from 0 to 50, 100, 150 and 200 Newton, and when the load was removed from 200 Newton to 0 Newton for both specimens. The results were recorded in table 2 for brass shaft and table 3 for mild steel shaft. Thank you.
Okay, next I will present about results. First, we fill up the table 1, which is diameter of specimen. After we measured 3 times of diameter and gauge length, we calculate the average of each shaft, brass and mild steel. Average are useful because they summarize a large amount of data in a single value and indicate that there is some variability around this single value within the original data. After that, we fill up table 2 and table 3, which is torsion test result for brass shaft and mild steel shaft. After we record the all data, we plot the graph, which is graph of load versus angle of twist for both shaft. Our observation in this experiment is first, average value for diameter and gauge length of specimen is taken to get nearly original data in this experiment. Next, when the load increase from 0 Newton to 200 Newton, the angle twist also increase. When the load decrease from 200 Newton to 0 Newton, the angle twist also decrease. My next point is angle of twist of brush shaft is higher than mild steel shaft during addition. And my last point is angle of twist for mild steel shaft is near to its originally position after removal of load compared to brush shaft.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal Bibimano and I will present about the calculation and discussion for torsion experiment. First thing first, you must find a torsion constant result, which is they already give as a formula, which is torsion constant T equal to F multiplied by R. So you just put your value into F and R, you will get a torsion constant from 0 to 200 Newton. And after that, you must convert degree unit to radian for angle of twist using formula. They already give the formula at the module, so you just follow the formula already given. So you will get shear modulus result for brass, and you will get shear modulus result for mild steel. The same 0 until 200 Newton. Then after that, we must find a shear strain and shear stress for mild steel and brass. So we do like the before, which is the same. They already give the formula, so you just put the value into the formula, and you will get a shear strain for brass and mild steel and shear stress for mild steel and brass. And after that, we will go through to the discussion. 4.1 is while performing the experiment, the human error while calibrating the equipment, applying load and taking reading can cause alter the result. The limitation of the machine can also cause error in the reading. As we know, when we do the experiment in a real life, our result does not exactly the same as the format in the module, so we need to take a precaution to make sure our result does not far away from the format in the module. So point 2 is failure mostly occur at the point which has any internal defect or crack. If not, the point with highest stress concentration will be point of the failure. And point 3 is mild steel is stronger compared to brass and more suitable to use for the shaft. As the result we already get, and the calculation we already know the mild steel is more suitable than the brass for the shaft. Then there is a question, which is if the cross-section shaft is not a cylinder, explain how to perform a torsion analysis. For this question is, we use a warping that is unique to section that are non-circular or cylinder cross-section. Warping is a square cross-section was clearly demonstrated by using specimen of square cross-section. Second question is, briefly explain some of the important factors in designing a high quality shaft. So there are 4 main points in this question is we must improve ductility, malleability, toughness and hardness. So for the ductility is material ability to undergo significant plastic deformation before rupture or breaking. So shaft need a higher ductility, so when experiment shaft will not easily have problem to handle. And second is malleability. Malleability is ability to hammer, press or roll into thin sheet without breaking, which is shaft need to be higher malleability to make sure shaft is stronger and have no problem to handle stress in the experiment. And the last point is hardness. What is mean hardness? Hardness is to measure a resistance to localized plastic deformation induced by either mechanical agitation. But hardness is depends on ductility and toughness.
My name is Amir Zahiri. I'm from Group 7, and now we're gonna talk about conclusion and recommendation for torsion test. First of all, we can conclude that mild steel has the maximum value of modulus of rigidity than brass. This is because of geometric properties like polar moment of inertia and the calculation also conclude that we can differentiate the materials and predict their behavior under torsion test. For recommendation, the value for recommendation we have parallax error, misalignment error and systematic error. For parallax error, we must make sure that our eyes are aligned with the tools of measurement. And misalignment error, there are some like the dial gauge is not vertical or the vernier caliper is not perpendicular. So before we measure that result, we must make sure of this first. And then the third point is systematic error, such as that the vernier caliper, we must make sure the plus minus and the zero error. That's all for today. Thank you.